Hello everyone, welcome to the channel Code Breakers. My name is Manjay Kumar. First of all, happy Shivratri to everybody. So in this video, we will be covering the merge sort algorithm. So first thing first, what is a merge sort algorithm? So basically, merge sort algorithm is an algorithm which is used to sort the arrays. So we will be given sort of arrays elements, and we are going to sort these either in the either in the ascending order or the descending order. So in the previous lessons, we have discussed about the selection sort, insertion sort, bubble sort, and many. Okay. So why there is the use of this merge sort? So basically, the selection sort, insertion sort, and bubble sort, they use the time complexity of order of n square, right? But since this time complexity is quite bigger, so we are going to implement a sorting algorithm which uses the time complexity of order of n log n. We will discuss the time complexities further. So let's begin. Okay. So here we have been given this array like 38, 27, 43, 3, 9, 82, and 10. So we are going to sort this array. Okay. So here in the right, we have been given a code. So this is the basic code we are going to follow in the merge sort algorithm. So it has 4 steps. Okay. So first thing first, let's begin. Okay. So initially, the merge sort what does is it divides the array into two halves and starts iterating through these halves. Okay. So since this is a bigger problem, okay, and we will divide the array into two halves and we will make it into a smaller problem. Okay, and since this is smaller problem, it gets divided into more smaller problem, so hence we can recursively iterate through the array, and then we can initially merge the array and then we can sort the array. Okay, so let's start. So initially my start pointer will be here, that is the begin pointer, and end pointer, that is basically the end pointer. Okay, so coming to this code, so here we can say that, let's say this begin is starting S and this ending is E. Okay, so we are saying here, okay, um, is this starting pointer greater than equal to n? I mean basically when we are going to iterate, when we are going to reversely call this function, so whenever our start pointer gets greater than equal to n pointer, that means we are left with an individual element. Then we will come out of the loop and we will actually merge this array. Okay, so let's see. So initially starting pointer is 0, ending pointer is 6. So since starting is greater than not greater than equal to end pointer, so we will move forward. So we will calculate the mid at this statement first. Okay, so what is the mid? Mid will be 6 plus 0 divided by 2, that will be 3. So this array will be divided into two parts. Okay, and then we will again go here and we will check. Okay, so is 0 greater than equal to 3? No, right? So we will again come here at the first statement, we will again divide it into two parts. So now we will have elements like 38, 27, 43, and 3. Now our end pointer is basically 3. Okay, now again we will check whether start is greater than equal to end. No, right? So we will again divide. So now our mid pointer will be this. Okay, so we will divide it into further two halves. So the left half will be 38 and 27. Now is starting pointer greater than equal to end? No, right? So we will again divide into two parts. Now we will be left with an individual element, that will be 38. So now Now we can say that the start is 0 and end is also 0. Okay, so we can say that begin is equal to end, so we will return from this. Okay, so after returning we will go back here at the third step. So at the third step we will follow this right half, so 7 will come here. I mean this is 27. Okay, and then after completing the third step we will move towards to merge the array. Okay, so we are left with these two arrays 37 and 28, so we will merge this. So basically we will discuss the merge function separately. So merge function, it merges two arrays. These two arrays will be sorted and we will merge these two sorted arrays. So since 27 is smaller than 38, so 27 will come at the first iteration. Okay, so 27 and we will be left with 38, right? That's fine. Now since we have completed this second step, so now we will come to this step. So 43 will be here and 3. Okay, now this will go here. This will check, is begin greater than equal to end? No, right? Because we have two elements. Whenever we have one element, then we will return from this array. Sorry, we will return from this function. Okay, so we will further divide into two parts. This will be 43 here and 3 here. Okay, now as we have completed this third step, so we will move forward and we are going to merge these two arrays. So what will be the final output? So we are left with 3 first because 3 is smaller than 43. So we are going to get 3 first and then 43. Correct? Yeah. So after that, we will merge these two. Okay. Now see. So we will get 3 first because 3 is the smallest, and then we will get 27. Of course, we will discuss this merge sort, merging, how merging works separately. Okay. And then which element we will get? We will get 38. Okay. Fine. And then at the very last, we will get 43. That's fine. Okay. So after this, we will move towards the right half. So we will have 9 here and then 82 and then 10. Okay. What is start pointer here? Start pointer is 4. I mean start index is 4, and what is the end point, end index? End is 6. So we will check, is start pointer greater than equal to end? No, right? So we will divide. We will calculate mid first. So what will be the mid? Mid will be uh, mid will be this. Okay, 10 divided by 2, that will be 5. So mid will be this. Okay, so we'll divide into two parts. That will be 9 here, and then we will have left with 82. Correct? Yeah. And then this 9 will come over here, and then we will come with 82. Because these are left with a single element, so we will move towards the right end. Okay, and then we will merge these two. Okay, so since 9 is smaller, so 9 will come first and then 82. Okay, Great. And after that, we will be left with single element, that is 10. And now we will merge these two. So what will be the output here? We will be left with 9, then 10, and then 80. Of course, we will discuss this code in this video itself. Yeah. Okay. So now we discuss how this merging happens. Okay. So we will begin with one sec. Yeah. So we will merge these two arrays using the two pointer approach. So we will point I here and j here, right? And now we will, since we have to merge this array, so we will have to create a temporary array. The temporary array will be the size of these two arrays, and we will sort this into this temporary array. Okay, so 1, 2, 3, 4, 5, 6, 7. Okay, so now we will check, is ARR of I less than ARR of j? That is 3 less than 9? It is correct. Okay, so we will fill 3 here and we will increment the I pointer. Okay, so now I will be pointing to this, and now we'll check, is ARR of I less than ARR of j? So is 27 less than 9? No, right? So we will append 9 here, and now we will increment the j pointer. Okay, so now j is pointing to this. Now check, is 27 less than 10? No. So we will append 10 here and we will increment the j pointer. So now j is pointing here. Now check, is 27 less than 82? Right. So we will append 27 here and we will increment the I pointer. So now I is pointing here. So is 38 less than 82? Correct. So we will fill 38 here and we will increment the I pointer. So I is basically pointing now here. So is 43 less than 82? Correct. So we will fill 43 here and then we will increment the I pointer. So I has gone out of the bound. So now we will fill 82 here, and yeah, we have sorted this array. But this is temp array. So what we have to do is we have to fill this temp array into the original array. Okay. So of course we have to write logic for this also. Okay. Fine. So let's move to the coding part. Okay. Yeah. So let me open this. Okay. Why it's taking too much time? Yeah. So let me create an array of 10 elements. 9, 10, 9, 8, 7, 6, 5, 1, 2, 3, 4. Okay. So we are going to call this merge sort function. The arguments will be array, and we will pass the start pointer and the end pointer. So pointer will be basically 0 and the end pointer will be n minus 1. What is n? N is 10 here. So n minus 1 will be 9. And now after this function, I'm just printing out our array and checking whether the elements have been sorted or not. Yeah. So I will say if start is greater than equal to end, then I will simply return. Now we will call this recursion for the left and right part. And then we will call this merge function, which will merge two arrays. Now let's make this merge function. Right. First we will calculate the mid. Okay. After mid we will calculate size. Will be and minus. Now we will create two temp arrays. The size of the first will be L1, and for the second the size will be L2. Okay. Now let me create a start variable that will be pointing to start initially as initially. Now we will fill this temp arrays. Now start will be mid plus 1. Why? Let me explain this. So basically this, okay. So since we have created this first array, temp array, so after that we are going to create another array. We have another array of temp array. Okay, so the start is this for this part, this temp array, and now for filling this part, this temp array, the start will be mid plus 1. What is mid here? Mid is this, so mid plus 1 will be this. I mean mid plus 1. Okay, good. And I is equals to 0, z is equal to 0. Oops. Yeah, now I 0, j will be 0, start will be s. Okay, I is less than L1. Now since we have filled this temp array, now we will move into the final array. So yeah, we are done with the code, I think. So let's run this code. So mid was not declared. Okay, okay, okay. Let me check what is the. Yeah, so sorry, we have not calculated the mid. Start plus n minus start divided to great. Yeah, so you can see we have sorted the array. Okay, great.